Today we are going to build 3.5-inch FPV drone. So please join me to share some fun and challenges everybody who is building their own drone is inevitably facing. Also, please make sure you subscribe to my channel because this will be a series of videos, and to make sure you're not missing any of them, it would be better if you subscribed. Hey guys, just a little bit of a teaser. We are currently in the field for the first flight. This is what we've got so far. So if it's something interesting for you, please subscribe to my channel and watch videos in this series. And also please note that all parts used for this quad are linked in the description down below. And back to the build. Time to solder ELRS receiver. So ELRS receiver, it has 4 parts. It's ground, 5 volts, TX which is going to RX on flight controller, and RX which is going to TX on flight controller. So on a flight controller we will use these 4 pads. It's those are for TX RX, and this is for ground and for V5. So if we look at our diagram, we'll see that here's our ELRS receiver. So it's going to JI and for V5 and ground. So for V5 is different from normal V5 5 volts in the way that it has its power when you plug in USB actually. So it's very useful for ELRS receiver and GPS module to get powered with USB only, and normal 5 volts is only giving you 5 volts when you plug in the battery. So let's now solder the receiver. This is how we soldered wires to receiver. So black goes to ground, 5 volts goes to 5 volts, TX is going to RX, and RX is going to TX on a flight controller. And my rule of thumb is that my white wire is always going to TX on a flight controller. So whenever I see white wire on my build, I'm pretty sure it should go to TX on a flight controller. Now I will take my receiver, I'll put it like this and into heat shrink. The reason for that is I'm gonna mount it something like this. I'll solder the wires to the parts, and what I will do, I will fix antennas on the arms, left and right. It's a dual antenna receiver we are using. It's not a true diversity, it's just antenna diversity, just for better, but there is one chip on the receiver. So what we can do is just to mount antennas in the way so we have maximum receiver strength out of 2 antennas. Here we go, VTX is soldered now, so we'll just put some heat in a heat gun and fix it over there. What I will do now, I'll take a bit of an alien tape, which is both-sided sticky tape, and I will put just a little bit on the bottom and stick it to the connector on VTX. Next, I'll put some zip ties. I'll put zip tie in here, and I'll put zip ties on an arms to hold the antennas. This is how our receiver looks after installation. It's quite securely locked here with Allen tape and zip tie. I also have XT30 wires going through the same zip tie. What happened as well, I've replaced those rubber temporary holders with zip ties on the arms, put some mechanical tape to lay antennas nicely and secure the antenna by 45 degrees. I haven't used the dedicated space because I want antenna to be 45 degrees oriented. In case I have just one antenna, I would definitely use space provided in TPU. And now we can try with our smoke stopper. Okay, so it seems we are good. We have some blinks on our receiver, but it's not yet over because we need to connect it to our transmitter and to our let's say joystick or control module, and we will do it now. As soon as we are happy with our smoke stopper, we can continue to bind the drone to our controller. So if you have one controller, one drone, the easiest way would be to plug in your drone, turn on your radio, click Sys button and click ExpressLRS, go to scroll down to bind and click bind the button. That will bind your drone to your controller. That will work if you have one controller, one drone, but what if you have multiple controllers and multiple drones? You want more universal way, and that's what we will do today. It needs a little bit more setup in the beginning, but we will go through it. So we will disconnect our drone. We will connect it to upper USB connector on our flight controller, and we will select USB serial VPC. After that, we'll need to go to ExpressLRS Configurator website. Here it is. It's expresslrs.org. Quick start installing configurator and download ExpressLRS Configurator. As soon as you download and install it, just open it and select latest version of ExpressLRS, select your device. In our case, we have RadioMaster 2.4 GHz, but there are multiple devices and listed here. So your one is, if yours is not Pocket, but it's RadioMaster, it would be here anyway. For the particular model, we select RadioMaster Pocket internal. For flashing method, we select HTX. HTX is an operating system running on the controller, so it will use operating system capabilities to run through to flash our ELRS. For domain, if you are in Europe, you are obliged to select 2.4 GHz LBT, listen before talk. It will also limit your maximum power of radio module on the controller to 100 milliwatts. If you are not in EU, you can safely select 2.4 ISM, which will be 250 milliwatts for your radio power output. And then what's important here is to use a binding phrase. Binding phrase is a concept by ExpressLRS which interconnects all the devices with the same binding phrase. So if you have same binding phrase on multiple controllers and on multiple drones, you can use each drone with each controller. Then in here you can you'll probably have your port after selected, and then what we can do, we can just click flash. I am in Europe, by the way, so I have to use LBT. Now we are trying to initialize COM port, and Here we go, now it's being flashed. That's it. We have one warning update Lua script, so you click on download Lua script and save it somewhere on your computer. Then what you are doing next is you just disconnect USB cable and connect it again. And instead of USB serial, you just select USB storage. This will open a new USB drive for us, and you will see USB drive. It will be a flash disk in our radio module. So what needs to do, you need to go to your place where you stored your Lua script, and then back to your drive and go to scripts, tools folder, and put the file here. It might be, it's already there, but it might be not latest. That's done. Now we can jump onto receiver itself. Hey guys, just a word of warning here. So sometimes RadioMaster Pocket is not properly recognized by a Windows computer, and to fix that situation you need to go and install special driver from STM Electronics. It's like virtual COM port driver. Otherwise you won't be able to flash your radio, and radio won't be recognized by your computer. I put a link to driver download page in the video description down below, so check it out if your Pocket is not properly recognized. One thing we need to do after we flash ExpressLRS is to go and check our ExpressLRS packet rates. To do this, again, press Sys button and then click ExpressLRS, and your first settings would be packet rate, so make sure you are on 250 Hz. So it's a good trade-off between range and performance. The more packet rate is, like let's say 500 Hz, the more performance of ExpressLRS, but the less the range is. So 250 Hz is pretty much standard, which everybody else is using. It's time to flash ELRS receiver on the drone, and to do that, just connect it to USB and wait for 1 minute while it goes into Wi-Fi mode. So ideally you know what your manufacturer and model of your receiver is, and I know that it's RadioMaster RP3, but in case you don't know, or you grabbed some old receiver from your shelf and you don't remember exactly what the model and manufacturer is, let's just wait for 1 minute until it goes into Wi-Fi mode, and then we will see what's installed on this radio module. So once the minute is over, it goes into Wi-Fi mode and starts flashing very frequently. That means that we can now connect to its Wi-Fi, and to do that you just go to your Wi-Fi networks on your PC and select ExpressLRS network. Once you connect it to ExpressLRS Wi-Fi network, it will open the radio starting page, and we will see that it's ExpressLRS, RadioMaster RP3 Diversity 2.4 GHz RX, and it's on latest firmware because I flashed it already just as experiment, but it was 3.3.1 initially. So and to actually flash a new firmware, we just need to go back to, just remember your model and manufacturer of your receiver and go back to our normal Wi-Fi. After we are back to our Wi-Fi, let's go back to ExpressLRS configurator, pick latest ExpressLRS release, and pick our RadioMaster 2.4 GHz device and our concrete device, RadioMaster RP3 Diversity Receiver. Here we need to select Betaflight pass-through. Again, ISM or LBT, it's on you. And binding phrase, that's most important thing. Binding phrase the same as on our controller. And Now click flash. Here we go. We are done now with the flashing. Now, as we flashed both controller and drone, let's turn on our controller.
Welcome to HTX.
And let's connect our flight controller.
Telemetry connected.
Woohoo! We are done now, so we established connection between the radio module and the drone. And the next step would be to test our receiver and function in Betaflight. Now let's go to our Betaflight and click connect. And what we need to do, we need to go to receiver tab and see if our drone and receiver interact with each other. So, oh yeah, here we go. We have everything working, like throttle is throttle, yaw is yaw, pitch is pitch, and roll is roll. That's good. We are happy to have everything working now. Just make sure if something is wrong with in your case, just make sure you have serial, CRSF, you have telemetry on, and if, for example, if you have left and right part in mixed, just maybe try to play with channel map settings. But in our case, we are all good to go. So that's it for the receiver, for the ExpressLRS receiver. We are now connected with our controller and we are happy everything is working as expected. Hey guys, thanks for watching. Just wanted to remind you that all parts used in this build are linked in the description down below. Also, I would appreciate if you subscribe and like and put your opinion in the comments down below. Thank you.